Today our focus is going to be paper 2. So we're going to go back to the front cover of that summary page. And if you take a look at that, what you're going to see is the cognitive level weightings in your paper 2 exam is different from that of your paper 1 exam. Okay, so in order to get 50% for paper 1 exam, what you need to do is you need to know all of your definitions, all of the things that you can literally put into your brain and vomit onto the page. You want to know all of that. And you want to know how to do all of those questions involving calculations. If you can do that in a physics paper, you will get your 50%. But it's not the same for chemistry. And sometimes, because you guys like math so much, you think it's the same and you focus on the complicated calculation questions in chemistry. But if you look at a chemistry paper, if you would like to obtain your 50%, you need to know all of your definitions, all of the things you need to memorize off by heart. You need to know those. And then also, for a chemistry paper, you need to be able to explain yourself in words, which is sometimes very, very challenging. When you know the differences in the cognitive levels, you will know the things to focus on so that you can get the marks that you are looking for. So if you are someone who struggles, again, with the English language, you're going to have to practice and practice and practice until you get those explanations correct. And in the chemistry paper, just like in the physics paper, my suggestion is exactly the same. Answer questions that require explanations using bullet points. It's going to allow you to organize your thoughts so that you don't write a long essay where you go in circles about the same concept. And it's going to make it easier for the examiner to mark the paper. Okay, so if it's out of 3 marks, I need to see 3 different points, and please write them out in bullet point form. Okay, a reminder, for your chemistry paper, there are not as many topics as for the physics paper, but the problem with the chemistry paper is that most of these topics begin in grade 10. And because of the pandemic, a lot of you were in school twice a week and so on, and that really took a toll on your understanding of all of these concepts at the moment. So guys, in terms of calculations, you need to know everything on quantitative aspects of chemical change from grade 11. What I'm talking about there is stoichiometry, using mole ratios. Do you understand how to calculate concentration? Do you know how to use mole ratios to go from one value to another? Limiting reagent, which I know a lot of you don't like, but very, very important in the acids and bases section. Percentage yield, percentage composition, empirical formulae, all of those things that started actually in grade 10. You need to know this year, and if you're someone who's battling with the level 3 questions in a chemistry paper, those questions that require calculations, it's possibly because something went wrong in grade 11. So please make sure, guys, that you know your grade 10 and 11 chemistry, quantitative aspects of chemical change. Otherwise, you are going to battle with those concepts, especially in acids and bases and chemical equilibrium. Now, I know that Mr. VG has already told you guys about juniorturkey.online, but I just want to show you guys. If you go and you register on this website and you go to the grade 11 content, you're going to see over there, there's an entire chapter on Newton's laws. So if you're struggling with Newton's laws, there are videos and documents there for you. Mole calculations, all of those things on quantitative aspects of chemical change. There are videos and other resources there for you guys to use. Electric circuits, atomic combinations, right? That's there. Electrostatics, which you guys know you will be tested on this year in your physics paper 1 exam. There's a whole chapter on that. So please go and register and go and make use of these resources. Okay, now if we go on in this list, you're going to see the next thing that is there is energy changes in chemical reactions. There we are talking about those potential energy diagrams. Do you guys understand what a catalyst does to a reaction? Do you know what an activated complex is? Do you know what the activation energy is? Do you know the difference between an exo and endothermic reaction? This is grade 11 content that you must cover because we do ask about it every single year. Okay, rate and extent of reaction, that of course is grade 12 work. Chemical equilibrium. Do you know how to identify when you are dealing with chemical equilibrium versus a reaction that has gone to completion? Those things are very important. Acids and bases. If you go back to your juniortikkie.online website, you're going to see over here, guys, there are videos on work, energy, and power, the physics content that you guys struggle with, acids and bases. When I first started teaching, I really battled with acids and bases. I'm a physics major. I love physics, not so much chemistry. And I actually used these videos in order to make sure that I understood the content. So I really suggest that you go and watch all of these videos on acids and bases, download the worksheets and work through them. If they can help your teacher to teach you, then they can definitely help you to get through your exam. Okay? Chemical equilibrium, there are videos and resources on that. And then you're going to see there's a whole lot of other things that you guys can use, mole calculations for grade 12 as well. But I'll leave you guys to go through that. It's very, very useful. So please don't neglect to go and register on that website. It's going to help you. It's going to save you. Okay, electrochemistry. Now, guys, I found in the past that a lot of learners found electrochemistry to actually be an easy and manageable section. But because it is now taught at the end of the syllabus, because we've taken chemical systems out, you guys actually struggle with this a lot. So if there are any of you that are really battling with electrochemistry, I'm going to touch on it a little bit today, but I actually have videos of my own that are not on the juniortikkie.online website. You're going to see that there are videos here on the same topic. Here they are. But I created them a long time ago and I'm not very proud of them. So the reason why my new videos are not on this website is because I made use of a textbook. And unfortunately, if they get posted here, we're going to get in trouble for copyright infringement. So if any of you are interested in those videos, after this, you just send me an email and I will send the link to you. You're going to see in that summary booklet, my email is all over the page. So just send me an email, say, ma'am, I need videos on electrochemistry, and then I've got your back. I teach everything in detail as if you are a learner in my classroom who needs to know everything from scratch. Okay. Then we also have in the chemistry paper, organic chemistry. You normally have 3 questions on organic chemistry. The first one is on the nomenclature rules, knowing how to name compounds and so on. You guys must know the differences between the different types of formulae, please. Grade 12, when we say write down the name of the formula and you write down H2SO4, you're not going to get your mark. When we say write down the chemical formula and you write down sulfuric acid, you're not going to get your marks. Sometimes we test your understanding of physical science. Other times we check to see if you understand instructions. So when you read through your chemistry paper, make sure that you read carefully for what they are asking for. Do they want the name or the formula? Please make sure that you read on that. The second thing over there is your physical properties. There we're dealing with the intermolecular forces and so on. And lastly, the different types of reactions in organic chemistry. So there are actually 3 different topics in organic chemistry. If you are trying to get a 40% for your paper 2 exam, you can get a 40% by just knowing, oh, that's a bad 40, by just knowing everything on organic chemistry. Okay, this is 40% of this year's paper. The other 60% is all of this at the top. So if you want more than 40%, you need to make sure that you go through all of these other topics as well. Okay, so let's go and take a look at the content. If you take a few, well, if you go through the pages, so if you skip past all of the physics sections, you're going to see that the summaries for your chemistry paper are in the same summary booklet. Guys, I've done my absolute best to try and summarize, but it's very difficult for chemistry because there's just so much theory in chemistry that you guys need to know. So just to quickly go over it, all of the different definitions that you need to know, you're going to find in this section. If you don't know what a hydrocarbon is and the difference between a saturated and unsaturated hydrocarbon, you're going to find it there as well. Your homologous series and functional groups, they are the definitions. Now I want to bring you guys to this part over here. I copy-pasted this from your exam guidelines because every single year they're going to ask you for the functional group of some type of compound. They will either ask you to draw the structure or they will ask you for a name or description. Please make sure that you learn these structures exactly as they are here. They differ in textbooks. They're not the same in your textbooks. And if you write them down how they are in your textbooks, you're not going to get your marks. If ever we ask you for the structure of a functional group, we need it exactly as it is on this page. So please go and learn this, circle it, star it, but this year is very important because I find that learners get this wrong every year. Knowing the names of the functional groups, if we look at the alcohols, there it's called a hydroxyl. If you look at the aldehydes, there we are talking about the 4-mile group. Ketones, the carbonyl group bonded to 2 carbon atoms. And your carboxylic acids, there we are talking about the carboxyl group. You need to know the names of these functional groups and how to draw them according to your exam guidelines. And again, this is copy-pasted from your exam guidelines. Then, chain isomers, positional isomers, functional isomers. Guys, these things are all called structural isomers. So in other words, you get 3 different types of structural isomers. Number 1 is chain isomers, number 2, positional isomers, and number 3 is functional isomers. If we use the term structural isomers, you can give us any one of the 3. But if we are specific, then we are looking for the specific type of isomer. Please make sure that you know the difference in the terms and how to identify the difference. I'm going to point it out very quickly. I know you guys said you're interested in the other things, acids and bases and so on, but just very quickly. The way I am able to identify the different types of isomers is I write down the names of whatever I'm given. So step number 1, if you would like to determine what type of structural isomer you are dealing with, name the compounds. Now we say a chain isomer is molecules with the same molecular formulae, but different types of chains. So how do we name chains? We name our chains differently using meth, eth, prop, but, pent, hex, hept, oct, so on. And based on that, I know that these 2 are chain isomers because here we have but for 4 carbons, here we have prop for 3. And based on this word over there, I know that we are dealing with chain isomers. If we compare that to the positional isomers, we show position of different substituents. When I say substituents, I'm talking about branches or functional groups. We show positions by making use of numbers. So look at these compounds. Here we have chloropropane, chloropropane. They are both prop, indicating we have 3 carbons. So they are definitely not chain isomers. But what has changed in these names? It is the numbers. We went from 1 to 2. That is how I know it is a positional isomer. The names are going to save you. Lastly, if we talk about functional isomers, these ones are a little bit easier to identify. We know it is esters and carboxylic acids, okay? And then aldehydes form functional isomers with ketones. Now, how I remember the difference is I make use of the alphabet. C comes at the front of the alphabet. It's before E, it's at the beginning. So I know the functional group is on the first carbon. E is somewhere in between, so I know the functional group is somewhere in between. It looks the same, but that's how I know I'm dealing with functional isomers. If we look at A is the first letter of the alphabet. So I know in aldehydes, the functional group is on the first compound, but in ketones, K is somewhere in the middle in the alphabet, so the functional group is somewhere in between. That is how I identify the difference. You find your own method. Another way is to look at the names. Here we have methyl methanoate. Here we have ethanoic acid. So we are seeing that the end name is changing because we are dealing with different functional groups. Okay, are there any questions on that? In the next question on organic chemistry, we deal with the physical properties. For these three definitions, it's all or nothing. We don't give you part marks because you have had to know these definitions since grade 10. So please learn them off by heart. You are also going to learn off by heart the different types of strongest intermolecular forces in the different compounds. Your hydrocarbons, which are your alkanes, alkenes, alkynes, they have as their strongest intermolecular force London forces. Then you're going to learn off by heart your haloalkanes, also known as alkyl halides, ketones, esters, aldehydes. Their strongest type of intermolecular force is dipole-dipole forces. And lastly, alcohols and carboxylic acids contain hydrogen bonds as their strongest type of intermolecular force. Grade 12, hydrogen bonds are intermolecular forces. They are not bonds. We call them hydrogen bonds because they are so strong intermolecular forces that we can compare them to the strength of the bonds between two atoms in a molecule. It's because they are so strong. But hydrogen bonds are a type of intermolecular force. They are not a bond. We overcome intermolecular forces, we don't break them. Make sure you state the words correctly and understand that the word intermolecular force does not mean the same thing as a chemical bond. Intermolecular forces are between molecules, bonds are inside of a molecule. So between you and I are intermolecular forces. There's relationships, there's a bond that's holding us together. It's physical science, that is why we are here. But if we talk about the bonds in yourself, it is the ligaments holding your arms onto your body, your fingers onto your hands, and so on. They are different things. Please do not confuse them, otherwise you're going to lose your marks. Now, if ever you are asked why one substance has a higher boiling point, a lower melting point, a higher vapor pressure, so on, you are always going to explain by making use of bullet points more or less in this order. Number one, you're going to tell me what the different types of intermolecular forces are. So this compound contains London forces, that compound contains hydrogen bonds. When you are done with that, if you find that they have the same type of intermolecular force, you are going to discuss the differences in the structures of the compounds. For example, do they have a different number of functional groups? Do they have a different chain length or molar mass? Or do they have different number of branches? You're going to compare that. And based on that, you are going to say, therefore, the one compound contains stronger intermolecular forces than the other. When you are done telling me which one contains the stronger intermolecular forces, you're going to go on and you're going to state how the intermolecular forces, this is actually a repeat, then you're going to state the energy required to overcome the intermolecular forces. So you are then going to say, therefore, this substance requires more energy to overcome its intermolecular forces. You're going to get 1 mark for any of these parts, so bullet point 1 and 2. You're going to get 1 mark for comparing the strengths of the intermolecular forces, and then you're going to get 1 mark for telling me more energy is needed to overcome the intermolecular forces in this substance compared to that substance. Yes? Yes.
And alcohol has only one. How would you write it down?
Okay, that's a very good question. Let's say we're looking at a alcohol. We know in our alcohol, let's do this, we're going to have our OH, for example. But if we are talking about a carboxylic acid, then we know we have the double bond OH. Okay, so let's try that again. So this is what we say. Let's say we are comparing both of these compounds. We can see that they have exactly the same chain length. So we know we are not comparing the length of the chains. But what is differing here is the functional groups. Now, based on the functional groups, given that this is an alcohol, we know the strongest type of intermolecular force is hydrogen bonds. Over here, we also know the strongest type of intermolecular force is hydrogen bonds. So step number one, we're going to say both compounds contain hydrogen bonds as their strongest intermolecular force. Now, if you compare this compound, the alcohol, to the carboxylic acid, we say the alcohol has one site for hydrogen bonds, while the carboxylic acid has two sites for hydrogen bonds. Okay, that is your next step. We are now comparing the structures and how they affect the intermolecular force. So step number two, where you're getting your marks, is for saying the carboxylic acid contains two sites for hydrogen bonds, while the alcohol contains only one site for hydrogen bonds. Next step, you're going to tell me, therefore, the carboxylic acid has stronger intermolecular forces. And grade 12s, the only reason I'm writing IMF is because it's difficult to write on my tablet. You guys must write down the words intermolecular force. The teachers are not going to give you the marks for saying IMF because not everybody knows what IMF stands for. You must write this out in words, please. Don't say HB, write out in full hydrogen bonds. So you're going to tell me, therefore, this compound contains stronger intermolecular forces for your next mark. And lastly, you're going to tell me, therefore, this compound will need more energy to overcome its intermolecular forces for the last mark. Okay, please make sure you state all of these points and that you indicate it in bullet point form so that you can get all of your marks. Does that answer your question? Are there any other questions? Yes. To be honest with you, I think that it's the order that I've indicated over here. Okay, so first your haloalkanes, then the ketones, then the esters, then the aldehydes. But normally at grade 12 level, we will not ask you to compare these between themselves, okay? Unless the one maybe has more functional groups or longer chain. We normally will have only one independent variable. Remember, guys, we can ask you, why is the test a fair test? A fair test is one where we only change one thing and have only one independent variable. So normally we will not ask you to compare these compounds with each other because it just becomes too complicated at grade 12 level. Is that okay? Are there any other questions, guys? Yes? You were asked to compare, sorry? Diamond. I know the word, but I can't remember what it means. I'm very sorry. I will check afterwards and then I'll get back to you. Okay, but I'm guessing that it refers to the number of sites for hydrogen bonding as well. Okay, anything else, guys? Are you from an IEB school? Not? Okay. If it's CAPS, you can mention it exactly as I have and you will get your marks. So based on what you're saying, if I'm marking your paper, I wouldn't know what that is. Rather stick to what we always find in a past paper, and that is the number of sites. Okay. Anything else? Okay, let's move on. Guys, I'm not going to spend almost any time on this. When it comes to your types of reactions, you are going to have to know these things off by heart. And that's what makes it difficult for us who love math. We hate learning things off by heart. But all of these different conditions, all of the different rules, Markovnikov's rule, Zaitsev's rule, you are going to have to learn them off by heart and know how to apply them. What I do is, as soon as I get into an exam, on this section, I go and I draw out all of the compounds if I have been given the names, or I go and I name them if I've been given the structural formulae, and I try to fill in the gaps in those flow diagrams before I look at the questions. I find that that calms my nerves and it makes it easier for me to answer the questions later. But all of these things, go and study them, go and learn them. A key difference that you're going to find is this. If we are looking at elimination reactions, the elimination reactions will always require a concentrated strong base or a concentrated strong acid. The others, whether they be substitution or addition, will require dilute strong bases or dilute strong acids. Think about it, elimination, we're trying to take something out completely, so we need something concentrated. There's a difference between the term concentrated and strong. Something is strong, especially acids and bases, based on how they dissociate or ionize in solutions. Okay, guys, if any of you have attended any SIP classes, that is actually where I learned this from. USA, right, we deal with addition reactions, and USA just means unsaturated to saturated means addition. Okay, if ever you are asked to state the type of reaction, please don't first say hydrohalogenation, halogenation, hydration, or hydrogenation. Always start off with addition, elimination, or substitution. First start off with the general word, and only if they say state the type of addition reaction, then be specific. But please try not to be specific unless you are forced to. So rather start off by saying addition. But USA means unsaturated to saturated, means an addition reaction has taken place. SU means if you start off with something that is saturated and the organic compound becomes unsaturated, then we are dealing with an elimination reaction because we remove something from the compound, that is SU. And lastly, if we go on to SSS or triple S or however you're supposed to say it, we are saying if it is saturated to saturated, then the type of reaction is a substitution reaction. And that's going to help you a lot when you are analyzing those flow diagrams. Okay, are there any other questions? Yes? Mm-hmm. So are you talking maybe about the conditions, so where we say in certain reactions we don't want the presence of water? Is that what you're talking about? Oh, so if you need to add water, what must you refer to the water as? Is that what you say? Guys, if you add water, water is a liquid. So let me just explain quickly the difference. Bases like NaOH or acids like sulfuric acid, their state is aqueous. That means they've been dissolved in water, and that is why we use the words dilute or concentrated. But if you are just adding water, water is a liquid. Okay, I can't see the water here, but water is a liquid. That is why we don't use the words concentrated or dilute, and you just tell me add water, and that is it. Does that answer your question? Yes. So what about it? So you are talking about, let me just find it. I know exactly what you're referring to. I just need to find it in my notes so that I don't mess up. Yeah, it is. Yeah, it is. So you are talking about this reaction. You are talking about the hydrolysis reaction, and you are saying in the one case you might use a strong base, and in the other you might use water. Is that what you're referring to? Okay. So if you look at the reaction differences, it's exactly the same. In the case where we are using a strong base, it's going to be a dilute strong base, any of the three, and mild heat. If you're using water, it's the water and mild heat. Okay, so both require mild heat. Did I get you this time? Dehydrohalogenation over here. Okay, what about your dehydrohalogenation? You wouldn't, because dehydrohalogenation is where you are you're eliminating something. You're taking something out. So you're going to see over here in the notes, I've added all of the reaction conditions. Okay, you must just read through them and then you're going to get all of the questions you're asking me about. Okay, if you have any questions afterwards, come see me. Okay, I just quickly want to go on to the other section. So guys, if any of you have any more questions on organic chemistry, I don't want to spend too much time on it because you guys did ask that we do the other content. Okay, so energy and chemical changes. Guys, there is a difference between activation energy and the activated complex. Okay, and we caught you guys, the Gauteng learners, we caught you guys out in the multiple choice section when we asked about these two and their differences. Okay, we asked what is a catalyst, and the first option was a catalyst is a chemical that will decrease the activated complex, and most of you selected that one. But actually, it decreases the activation energy. Please be very careful. You need to still know how to draw these potential energy diagrams for both endo and exothermic reactions. Remember, activation energy is from the reactant to the activated complex. But enthalpy change, right, or heat of reaction, is between reactants and products. You're going to show that over there. So what is the activated complex? That is this part over here at the top. And that is the unstable energy state between reactants and products. All right, guys, the only thing that I really want to point out in this question is if we compare this question, question number 5, to the next one, question number 6, there's a very, very big difference between the two. And that is the arrows. Over here they say we have a balanced equation and we see that the arrow only points in one direction. What does that imply? There's only a forward reaction, which means if we need to speak about a graph and explain what happens in the graph, you do not say that the reaction goes to equilibrium. Instead, in this case, the reaction will go to completion. This is not a chemical equilibrium problem because the arrow is in one direction. It's only when the arrow is in two directions that we are dealing with chemical equilibrium. Please be on the lookout for how these chemical equations are written. Okay, I'm now going to go on to chemical equilibrium. And I'm going to speak a little bit about that. I'm sorry I'm speaking a lot today and not giving you guys much time to breathe, but bear with me. Chemical equilibrium tends to be a problem area. A very big problem area, but again, it's because of how you guys answer questions. So you're going to see over here all of the definitions, the factors that influence equilibrium position and so on. Firstly, guys, there are many factors that will influence the position of chemical equilibrium. Pressure, concentration, temperature, they are going to affect the equilibrium position. A catalyst does not affect the equilibrium position. A catalyst will change or speed up the rate of a chemical reaction, the rate, but it will not change the equilibrium position. Then we can speak about the factors that influence the equilibrium constant, also known as Kc. Kc is not affected by the same things that influence the position of the equilibrium. Kc is only affected by temperature. This is very, very important because we ask about it every single year. Okay, now what does Kc mean? Firstly, I need you guys to understand that if ever I ask you to write out Kc, a Kc expression, this is not acceptable. You will not get a mark for writing down this Kc formula. I need actual formulae from the chemical equation. You're going to see it when we do a few problems now, but I need actual formulae. I know when we are teaching, we tend to write it this way, but this is going to get you a 0 for your Kc expression, so don't write it out that way. So what does Kc represent? Guys, if you get a value bigger than 1 for Kc, it literally means that we have a lot of product once we reach chemical equilibrium. That is what it means. If we have a Kc value, this should be the other way around, please correct this. If we have a Kc value smaller than 1, then it means once we have reached chemical equilibrium, then we have a lot of reactants present, a high concentration of reactants. Okay? If the number is bigger than 1, it means the top is big. We have a high concentration of products. If the number is smaller than 1, it means the concentration of the reactants is big. Because if you take any number divided by a big number, you're going to get a small number that is smaller than 1. Make sure that you know this and that you know that it is only influenced by temperature. The Chatelier's principle is a big problem. Not because you guys don't know it. You guys memorize this principle very, very well. But when you are asked to explain using Le Chatelier's principle, for some reason you guys always restate the principle. There is the definition. If I ask you to define it, you write this down. But if I ask you to explain using Le Chatelier's principle, you do not write this down. You must explain in the context of the reaction that is taking place. You're going to see that when we look at the questions in the exam paper. Okay. Now over here I have a chemical reaction that I just copied from a textbook, right? So you won't have it in your notes. How do I know that this reaction is for chemical equilibrium? The double arrow. So guys, in your test, in your exams, you guys must look to see if you have a single arrow or a double arrow. Normally, in rate and extent of reaction, we have a single arrow. We are testing your understanding of reactions that go to completion. But in the section on chemical equilibrium, we have a double arrow. Words that you must refrain from using, even though they are in my summary sheet, is equilibrium lies to the right or equilibrium lies to the left. In the past few exams, they have not accepted it. You guys must instead say the forward reaction is favored, or you say the reverse reaction is favored. They do not accept equilibrium lies to the left or it lies to the right, which is how it's normally explained in textbooks. Instead you say the forward reaction is favored or the reverse reaction is favored, please. Okay. Now in this section on chemical equilibrium, you need to remember to make use of Rice tables. Do not try to answer these questions by using first principles, normal stoichiometry. Please remember to use a Rice table, and if you must, when you get into your exam and you open it up, go to the section on chemical equilibrium and write down at the top Rice table. Because if you don't use a Rice table, you're going to get very confused. This year, some of my strongest learners did not use Rice tables because they were overwhelmed by the prelim exams. So please remember to use a Rice table in this section. When you write out a Kc expression, Remember to exclude liquids and solids, please. And also remember, you must write out the Casey expression using the chemical equation that has been given to you. So if we are looking at this equation that I have here, we will say the concentration, Kc, will be the concentration of SO3 squared over the concentration of SO2 squared plus, oops, not plus, you guys do that a lot, ne? Multiplied by the concentration of O2. This will get you a mark. But this over here at the top, which everybody seems to write down, so I was marking this question last year. Everybody wrote this down. You got 0 out of the 1 mark for your Kc expression if you wrote this down. You must write it down like this, where you only have gases and aqueous solutions in the chemical formula. Yes? Yes? Okay, her question is if she wrote this down without the squares over there, but then when she goes on and she, ooh, let's get rid of this black pen. But then she goes on and in the next step, she goes and she substitutes in the values. I'm going to use very simple values. So she goes and she puts a 2 squared over 3 squared multiplied by 1. And she actually makes use of them there. Oops. She makes use of them in the substitution step. Will you then get this mark for substituting and the mark for the Casey expression? And the answer is no. They are separate marks. If you mess up your Casey expression, we will continue to mark until the end. But you will lose this mark over there if you don't write this out correctly. There was another hand up. Is that okay? Yes.
Because we're so used or rather programmed to write the product over the reactant being the actual words.
Yes.
Can we write this being the following step and we'll still get the mark for
the formula. Okay. So guys, there are 2 things that we tend to do because we are programmed to do so. Okay. Because I know I used to do it as well when I was in high school. What I would do when I was in high school is when I wrote out this formula, I would include the liquids and I would include the gases, and then in the next step I would leave them out. That is what I would do. Or what we do is we start off by writing this down, and then in the next step we write out the correct version. Now technically there's nothing wrong with that, and we should continue to give you the marks. But sometimes we overlook it. So my suggestion is write this out on your question paper for yourself to see. Again, when I as a marker am marking the 1001th paper, I'm very, very tired. So I might not see what you wrote down below. My mind might immediately see this and mark it wrong. So don't risk it. Rather just write down the correct thing on the answer booklet and leave this on your question paper. Okay, so it's not wrong. You should still get your marks, but rather don't do so. Okay, any other questions? Yes. Mm-hmm. Mm-hmm. I understand what you're saying. Yes. Okay, so her question is, let's say that we have liquids. Let's say, for example, this substance, the oxygen over here, for some reason was a liquid. So what you would do is you would write it down over here, and when you do the substitution, you put a 1 in over there. Again, it's technically not wrong. That is what I used to do when I was in school for the solids and the liquids. But rather don't risk it. Rather leave your solids and liquids. I think I said gases a moment ago. I'm sorry. Leave your solids and liquids out completely. That's my suggestion. It won't be wrong, but I can't guarantee that you'll get your marks. Yes. Yes. So guys, if you have something, let's say we have a reaction. I know this one takes place at very high temperatures, but let's say we have oxygen gas reacting with hydrogen gas to form water, and for some reason this water is in the liquid form and not in the gaseous form. Okay, this will not work. Let's do it the other way around. Let's say the reaction was happening that way. liquid water becomes these two gaseous products. When you write out your Kc, my suggestion is you simply write out O2, there's going to be a 2 over there, multiplied by H2 squared, and leave out anything beneath it. If you want to put it over 1, you can. But don't go and write down the liquid's, what's it called, formula. Rather leave it out so that if we are tired and we don't realize what you are doing, you're still going to get your marks. Okay, rather be safe always. Remember, the person that is marking your exam is not your teacher. We're showing you all of these tricks. And guys, you must understand that as teachers, we all know a different amount of content in different areas. So while I know this rule that we are speaking about now, the next teacher might not, and therefore will not realize what you're doing and might just think that it's wrong. So please be very careful. Okay. Now, what I was speaking about earlier is the way you guys state your answers over here. This here is a physics paper 2 exam, which means that the way you give answers, the explanations, is 40% of your paper. And therefore, it is very, very important. So here I've tried to summarize as far as possible the disturbance, the reaction that would be favored, and so on and so forth. What I want to say is, when you are giving answers in an exam where they say to you, explain using Le Chatelier's principle, you sort of want to state what's happening here and what is stated over there in order to get your marks. You're going to see it when we look at the actual past paper questions. So I'm going to get back to that a little bit later. Okay? Over here I have graphs. I'm going to talk about the graphs again in a moment as well. But let's go to question 6 of that past paper, please. So over here they say carbon reacts with sulfur. As soon as you get into the section on chemical equilibrium or rate of reaction, you must pay attention to the details. This is a solid, which means it will not be included in a Kc expression. If we want to speed up the rate of the reaction, we will not do so by adding more of it. Instead, we will break it up into a powder. Pay attention to those details. Here we have a gas. They gave us an equation. How do I know I'm dealing with chemical equilibrium? We have the 2 arrows. Okay, so there's a forward and there's a reverse reaction. We normally speak about the things on the right-hand side as the products and the things on the left-hand side of the reactants. But we know for the reverse reaction, this is the reactant that will form those products. Okay. Now on the right-hand side, we have change in enthalpy or heat of reaction. Is this an endo or exothermic reaction? It's endothermic. When the change in enthalpy is bigger than 0, we know it's endothermic. You must make sure that you know this. They then go on and they say the system reaches equilibrium at a certain temperature T, and we are sealed in a 2 decimeter cubed container. This here is volume, and we will probably use it in our rice tables when we are making use or calculating concentrations. They then give us the Kc value, and they tell us this is the Kc value at temperature T, reminding us of the fact that Kc is only affected by temperature. Okay, Kc is only affected by temperature. Chemical equilibrium can be affected by other things, but Kc only by temperature. Now they ask you to state the Chatelier's principle. See over here, they will give 1 mark only if you leave out any of the important words. So you guys will have a look at that. But now they say, at equilibrium, 1 mole of carbon disulfide is present in the container. Calculate the concentration of the sulfur gas present at equilibrium. Fortunately, they gave us the Kc value. So what would we do? We'd go and write down the Kc expression. Here, they explicitly say, if the Kc expression is wrong, you can only get a maximum of 2 out of 4 marks. So if you mess it up, then and you follow, then you're going to get a maximum of 2 out of 4, 1 mark over here and 1 mark there, because your answer will probably be wrong if your values are subbed into this incorrectly. If we are looking at the rest of it, it says, if there is no Kc expression, or, guys, if you write down the Kc expression as products over reactants, if you do that, you're going to get a maximum of 3 out of 4 marks. It's all over there, so I'm pointing out things to you guys that you've actually had all along. So they subbed in the Kc value, they subbed in the concentration of the Ks2. To get that concentration, we say number of mole divided by the volume. It was 1 divided by 2, and that's where they got the 0,5. We get our concentration in mole per decimeter cubed. Please make sure that you don't leave out the units of measurement. There are many, many learners that leave out the negative on the cubed. Be careful, you leave that out, you're not going to get your last mark. Are there any questions about this? Okay, then they go on and they say, the volume of the container is now doubled. Volume. We taught you Boyle's law in grade 11 so that you would know the relationship between volume and pressure. What is the relationship between volume and pressure? Yes, they are inversely proportional, implying that if the volume is doubled, what is going to happen to the pressure? It's going to go down, it's going to decrease, it's going to half. Okay, so we immediately state to ourselves that the pressure is going to decrease. They say after a while, a new equilibrium is established. How will the amount of sulfur gas change as the new equilibrium is established? Choose from increases, decreases, or remains the same. Now, a lot of us struggle a lot with this, and I say so because I was one of those learners. The concept only came to me right at the end of the year. When we speak about concentration, not concentration, about pressure, then, according to Le Chatelier's principle, we must compare the number of mole of gas molecules in order to decide on which reaction will be favored. So this is what we do. We look at the mole ratio. What number is in front of this carbon? A 1. So if we look at the mole ratio on the left, we have a 1 and we have a 2. 1 plus 2 gives us 3 mole of reactants. On the right-hand side, in front of this, we have a 1. So we have 1 mole of reactant. What has happened is that we doubled the volume. So to get our answers or our marks, number 1, we must state that that results in the pressure decreasing. And you write it down in words so that you can actually get your marks. But first we state how the change actually affects the physical concepts that we know. How does it affect concentration, pressure, temperature? State that. State your observation. When we are done, now we come to this and we need to decide which reaction will be favored. Now, if we decrease pressure, guys, pressure is a measure of force per unit area. It means there's less force per unit area. So according to Le Chatelier's principle, the reaction that will be favored is the one that leads to an increase in pressure. An increase in pressure, if we would like more pressure, more force, we are going to need more particles. So since there is 3 mole on the left versus 1 mole on the right, we say that the reverse reaction will be favored because according to Le Chatelier's principle, the reaction that produces more number of mole will be favored. You're going to get a mark for telling me that the reverse reaction is going to be favored. Do not tell me the reaction lies to the left, or it moves to the left, or it shifts to the left. You will not get marks even though it's correct in textbooks. You must tell me reverse reaction is going to be favored. I see your hand, I'll be with you in a moment. And you must also tell me that, based on the Chatelier's principle, you don't need to even state the Chatelier's principle, the reaction that produces more moles will be favored. Okay, don't repeat Le Chatelier's principle. You guys always repeat Le Chatelier's principle and you state it again. I don't want to know the definition of Le Chatelier's principle. I want you to tell me in this context what is going on. Yes, sir, at the back you had a question. Are you okay? Oh, you are right. He noticed that I made a big mistake. I did make a mistake. You are right. Guys, I made a very, very big mistake. This is a solid. So when we calculate the number of moles, thank you for that. When we calculate the number of moles on the left, we don't take solids into consideration. We only look at gases. I'm very sorry for that. Fortunately, the number of mole of gas on the left is still 2. Okay, so everything else I said still holds, but you only add up the number of mole of gases. Pressure is about gases. Please remember that and learn from the mistake that I've now made. Thank you very much for that. Okay, so if we go down, again look and see. Firstly, they give a mark for saying what's going to happen to the amount of S. Well, if the reverse reaction is favored, the concentration of it is going to increase. We're going to increase the amount of it. But where are they giving the marks? They're giving a mark, number 1, for saying increasing the volume decreases the pressure. What we observe, what is happening to the physical quantities. Your second mark you are getting for telling me the reaction with the greater number of mole is favored. We didn't restate Le Chatelier's principle. We are telling the marker what will happen in the context of this question. And lastly, a mark for the reverse reaction is favored. Okay, please mark yourselves immediately when you are trying these questions to see where you're going wrong. And if you ever explain something incorrectly, write down the correction on your page. Go and correct yourself as though if you are marking in class. Because the more you interact with the memo, the more you interact with the correct content, the better your brain is going to remember to correct that mistake. Okay, the next question is a rice table calculation. I'm going to skip this for now because I want to focus more on the theory ones or the theory problems, but you guys are welcome to work through it and ask me questions about it later. I want to go straight to this graph. Most of the time people struggle a lot with these graphs, okay? And in order to understand them, you need to remember the following. Number 1, if we are looking at temperature. Okay, temperature is going to affect, so you're going to see I indicated it in your notes with stars. Temperature is going to affect the rate of both the forward and reverse reaction. If the temperature drops, the rate of the forward and the reverse reaction decrease because all of the particles in the container have less energy. So all of the particles will not collide as effectively as previously. If the temperature increases, all of the particles now have more energy and the rate of all of the reactions is going to increase, whether it's endo or exothermic. If we are talking about concentration, when we have gases and we change the volume of the container, then both the rate of the forward and the reverse reaction will be favored because the concentration of all of the gases will be affected. Okay, so looking at this graph, without looking at the memo, I'm going to give you guys 5 minutes. I want you guys to try and analyze it and answer it You can always peek at the memo if you need a bit of assistance, or put up your hand. But try it, just give you guys a break, 5 minutes, and then I'll go through it with you. Okay, grade 12s, let's continue. They said here, the reaction rate time graph below represents further changes made to the equilibrium mixture. The volume of the container is kept constant. Now, when I read this a moment ago, I did not realize this part, and it made the questions that you guys asked me very difficult, okay? But this over here is not on your question paper at the same position. I went to the top of the question paper and I just stuck it in. We are still on question number 6, so we are dealing with exactly the same reaction, which means the fact that this is an endothermic forward reaction is important. And if the forward reaction is endothermic, what will the reverse be? Exothermic, okay, and we must know that. So number 1, they said, what do the parallel lines between TA and TB represent? The correct answer there is chemical equilibrium. But if this was a section on rate of reaction, just like in the exam that you guys wrote recently, we normally give you guys mass and a time that's changing, and you might see something that happens like that. In this case, once it reaches this point, if there's only a forward reaction, then you must tell me the reaction has reached completion. There's a difference, and you will not get marked for either or. It's one or the other, so you must be specific and you must pay attention to those details, please. Okay, the next one says, what change was made to the equilibrium mixture at TB? Now here, we are dealing with gases. So we know if there was a change in pressure, both reaction rates would have to be affected, okay? If there was a change in temperature, because temperature affects kinetic energy and will determine whether the reactants or products have energy greater than or equal to the activation energy, we know temperature would affect both reaction rates. So based on the fact that, in this case, we see only one of the reactions is going to be favored, specifically the forward reaction, it leaves us with only one thing, and that is that the concentration of the reactants has increased. What we did was we increased this side, because when you increase this side, the forward reaction is favored. But let's be a little bit more specific. Can you increase the concentration of a solid? No. If we're speaking about rate of reaction, if you would like to use a solid to increase the rate of a reaction, then you will increase its surface area. You would take the brick and you would break it down into a powder. That is how we change the, what's it called, the solid. But if we are talking about concentration, then we will specifically say we have increased the concentration of this gas. Okay, so we have added more sulfur gas to this reaction. So if you take a look at the memo, you're going to see here they say, and they accepted any of these, they said increase the amount of reactant, or you could have said increase the concentration of the sulfur. But if you're going to speak about specific reactants, don't say increase the concentration of the solid, okay? Don't say you're increasing the concentration of this thing, okay? Then they say give a reason for the sudden change in the rate of reaction at TC. So this is what happened to us there at the back when we're trying to analyze this. We looked at it and we saw, okay, at TC, both reaction rates are decreasing. A big mistake I used to make when I was in high school is I used to analyze what was going on further than this point. So I would look at this part and try to understand this part. But when you are looking at a reaction rate graph, you look at what happens immediately and you base your answers off of that. So we are only interested in the parts that I have highlighted. What we are seeing here is that both reaction rates decrease. So the rate of the forward and the reverse reaction decrease. That is an observation that we are making. It wasn't told to us on the paper. Just like previously, where they asked to explain in Le Chatelier's principle, I said to you guys, start off by saying that an increase in volume decreases the pressure, because that is your observation. Over here, the first thing you must state, right over here, at this part, when you're giving the explanation, is that you are observing that both the forward and the reverse reaction rates decrease. Okay, I know I'm skipping to the next question, but you must state what you are seeing, please, because you're going to get a mark for that. Now, we've identified that both reaction rates are going to decrease. We have a decrease in reaction rate when we are dealing with gases if the volume increases, and the pressure decreases, or if the temperature decreases. Now, in this case, the way we are going to know that it can't be this is because they said to us right from the start, the volume of the container is kept constant. And if you skip that part, you would have spent a long time trying to figure this question out. Okay, but they told us volume stays the same. So that means pressure cannot affect this. And at 6.6.3, we need to say the temperature decreases. Are we happy with that, grade 12s? Okay, now the explanation. This is where you guys lose your marks because you keep restating Le Chatelier's principle. Let's do this and let's just move up. In the explanation, number one, we state what we observed. We observed that the rate of both the forward and the reverse reaction decrease. You must state that, what you observe, what is going to happen to our physical quantities, etc. You must state that. But what we also see is, look at this graph. The solid line, which is for the forward reaction, decreases more than the yellow line, which is for the reverse reaction. That means that the reverse reaction is still faster than the forward reaction. It means if we were to draw these arrows using long arrows to imply favoring, then we would say the forward reaction would be like that and the reverse reaction would be like that. Okay. So our reverse reaction, because it decreases less, is the reaction that is favored. The forward reaction, the solid line, because it decreases more, it is not favored. Okay, it decreases more, so it is not favored. I don't have a lot of money to give to my kids for pocket money, but the one that I favor, I at least give a little bit. That's not going to work. I thought the analogy would work. Let's scrap it. Okay, I thought I was onto something. It's not going to work. Okay, but anyway, let's go over here. They now say the reverse reaction is favored, or if you saw the forward reaction is faster, or if you said the forward reaction decreases more, then you got your mark. We didn't restate Le Chatelier's principle. We said what is happening in the context of the reaction. And as a result, or according to Le Chatelier's principle, a decrease in temperature will favor the exothermic reaction, and that is your last mark. Again, guys, I never, ever restated Le Chatelier's principle. I explained in the context of what is happening over here. Are there any questions? So what you observe, what Le Chatelier's principle says will be favored, the reaction that will produce a larger number of moles, the exothermic reaction, the reaction that will lead to a decrease in the concentration. That is what you say next, and next you tell me which reaction will be favored. Yes? Oh, so you switched the order. That's fine. Guys, the order in which you state these explanation points doesn't matter. You can switch them around, toss and turn them, but please use bullet points, because as you can see, when we use bullet points, we see what points we are making, and we don't go in circles about the same thing. Okay, is that fine? Guys, are there any other questions? Yes. You want me to scroll up? Yes.
See there,
Yeah.
2 TB.
TB, yes.
You said the answer to the question 6.6.2 is increasing sodium,
Yeah.
meaning concentration. Why not temperature then?
Okay, the reason why it's not temperature is because remember, temperature means a higher kinetic energy. Okay, so when you increase temperature, what should happen is this one should go up and the dotted line should also go up. Even if it doesn't go up as much, the dotted line should also go up. So we know it's not temperature because the rate of both reactions are not affected. Only one reaction is affected. Whenever you have a change in temperature, the reaction rate graph will be affected for both reactions. Okay, just like over here, can you see both go down? That is how I knew it was temperature. Is that okay? If you need more explanation, you can always ask me afterwards. Okay, is there any other questions, guys? Okay, let's move on then. The next section is your favorite, acids and bases. This is where the complicated calculations come in. Okay. Because we only have about 25 minutes left of the session, I really want to emphasize to you guys that this teacher is able to teach because of this over here. This little chapter on the juniorturkey.online platform. This saved me, it saved my life, saved my job, okay? So please go and watch it because it's going to help you a lot. This here is not from me or by me. It's Dr. Swanepoel, I think her surname is. And she starts at the grade 11 basics, which is where we actually fall short and the reason why we struggle with this section. So go and watch these. They're going to help you a lot, okay? So just quickly, we know there are two theories, Arrhenius theory and the Bronsted-Lowry theory of acids and bases. It's more common for us to ask you guys to explain or give the definition for the Bronsted-Lowry theory. And the reason is because it makes better sense. Guys, scientists are always chopping and changing things and making new discoveries. In grade 11, you would know the problem with Arrhenius theory is, number one, it takes acid-base reactions and it limits them to aqueous solutions. We can't define an acid and a base without water according to Arrhenius theory. The second problem with this is it only explains bases that are metal hydroxides. For example, sodium hydroxide. It does not explain why ammonia is a base. And that is why we drop this to some extent. We teach it to you guys because it forms the foundation. But then we go on to Bronsted-Lowry theory because it works in all cases. Even when we don't have water present, we can still define an acid or a base. So we know an acid donates protons. Guys, I went through the whole, just give me a moment. I went through the whole grade 11, né? I don't know how. I think the thing is, if you're a math person, you identify patterns, and based on those patterns, you sort of pick them up and you do what you do. But I never understood what the teacher was talking about when she used the word protons. The term protons in this section is a hydrogen ion. I did not know that. I went through grade 11 not understanding that. If you're one of those learners, this is your day. The proton that we talk about in this section is a hydrogen ion, and I'm going to explain it to you very quickly, very briefly. A hydrogen atom is made up of a proton and only one electron in the orbital surrounding that proton. How do we form an H+ ion? We form it by taking away an electron. Now look at this. If I take away the electron in that hydrogen atom, what am I left with? A proton. So guys, the reason why we talk about H+ ions as protons is because they are technically just protons. Okay, but if you missed that at some point in your life, this is your day. Proton is a hydrogen ion in this section. If we are talking about a base, it's a proton acceptor. As mentioned previously, strong and weak acids and bases refers to the degree of dissociation or ionization. We talk about Ka and Kb values. They mean the same thing as the Kc value, except we use A and B to refer to the acid or the base. So, just like if you have a Kc expression and you say products over reactants, when you get a Kc value bigger than 1, it means a large amount of products. If you get a Kc value smaller than 1, it means a large amount, of reactants. It's exactly the same for acids and bases. The reason why we say certain acids are strong is because when we calculate the Kc or Ka value, we get a big number. We say certain acids are weak because when we calculate the Ka value, we get a small number, because the extent to which the ionization takes place would be small in this case and very large in this case. Strong and weak do not mean the same thing as dilute and concentrated. Remember that for the rest of your lives, please. Okay. Here I mentioned concentrated acids or bases means a large amount or number of moles of acids and bases in proportion to the water in which they are dissolved. Dilute acids or bases means a small number of moles in proportion to the water it's dissolved in. Okay, so the OROS is not the OROS is not dilute. The OROS is not weak or strong. The OROS is concentrated or dilute. There we go. Okay. Guys, conjugate acid-base pairs, this causes a lot of confusion because of your substances that are diprotic or triprotic. So your polyprotic substances. If you look at H2SO4, if you take this and you react it with, let's say, water, which is an ampholyte, we know that this over here is an acid. So what do acids do? They donate protons. Since the water is in the presence of this acid, it will behave as a base. So it will donate protons to the water. Immediately what we do is we go and we say those protons with the water is going to go and form the H3O+. And then my learners drop down and they say, but ma'am, there's 4 H's on the left-hand side, 3 on the right-hand side. What's going on? Guys, we have not balanced this equation yet. We must be patient with the process. The rest of this, which is going to be the SO4, right, 2-, is now going to be in solution. This is an ionization reaction, and that's what I have. But now I must go back and I must go and balance it. So what we will do is we can go and put a 2 over here and we can put a 2 over there, and then it is balanced. Am I right? 6, 6, 0, 0. Yes, okay, there you go. Now it's balanced. So we go back and we're going to balance it. The point I wanted to make is about the conjugate acid-base pairs. Conjugate acid-base pairs only differ by 1 proton. So grade 12s, this is not the conjugate base of this acid. Okay, the conjugate base of this acid is H2SO4 is going to lose only 1 proton to form HSO4-. Is that why the hands were going up? Okay, guys, this over here is the conjugate acid-base pair. This shows the complete reaction. When we give it time and we allow this here to lose the extra proton, then we have the complete reaction. But conjugate acid-base pairs only differ by 1 proton. It loses 1 proton. Or if it's a base, it gains 1 proton. Please be very careful with that. An ampholyte is a substance that can act either as an acid or a base. You guys know that. Big problem is the types of acid-base reactions, or even just acid reactions. You need to know how to write these out. We say an acid plus a metal hydroxide. Guys, an example of a metal hydroxide is sodium hydroxide. Is going to form a salt and water. If we have an acid plus a metal oxide, an example of a metal oxide would be Na2O, sodium oxide. That is a metal oxide. Is also going to form a salt and water. But if we have a salt and a metal carbonate, okay, like sodium, NaC, let's go in balance, Na2CO3. Am I correct here? You guys must help me. CO3 is 2 minus. Am I right? I hope so. Okay. In this case over here, I'm not very good with this. In this case over there, then we are talking about a carbonate. You might have a bicarbonate, for example. So NaHCO3, for example, which you guys are more familiar with. In that case, we have a salt, water, and carbon dioxide, which you guys tend to leave out. The last one, acid and a reactive metal, is if we were just to react the acid with the metal. This last one is not an acid-base reaction, it's a redox reaction. Please go and write that down. Meaning, there is not an exchange of protons. Instead, there's an exchange of an electron. The difference between acid-base reactions and redox reactions is acid-base reactions, there's an exchange of a hydrogen ion. But redox reactions, there are exchanges of electrons. That's the difference between the two sections. Okay. This over here is a formula that we can use. Yes. No problem. Where is it? So it's probably somewhere over here. Maybe I didn't copy it in. But yes, it would be. Any definition. So even these ones, a bit lower. It's possible that I didn't copy it in. That's why it's not here. Do you see it? This over here, this would not be a definition that we'd ask for. This over here is something you'd have to apply. Is it? Then it would be for 2 marks. Okay. Guys, any definition, no matter how long or short, will be 2 marks. If we ask you to explain, sometimes it's only 1 mark. But definitions, always 2 marks. Okay. Guys, titrations, very important with this formula. You know that these numbers is not the number of moles that you calculate. It's the number of moles from the mole ratio in the balanced chemical equation. For dilutions, we make use of this formula. You don't have to, you can use first principles, but don't confuse titrations with dilutions. Hydrolysis tends to be a very big problem. You must know, when we have a, what did I write down here? A weak acid with a strong base, the end result is a pH bigger than 7. In other words, it's going to be alkaline. If we have a strong acid with a weak base, then we're going to get a pH smaller than 7 and it will be acidic. If you have a strong acid and a strong base, the pH will then be neutral or close to 7. Now the problem, the reason why this confuses us begins in grade 8 and 9. We have this idea that if you have an acid and a base and you mix the two together, you're going to end up with a neutral solution, because we use the word neutralization to describe acid-base reactions. Especially in titrations, we use the term neutralization. Neutralization actually does not mean, I repeat, it does not mean that the pH at the end is 7. It does not mean that. Neutralization means if I have 2 mole of acid plus, for example, 3 mole of base is going to form a salt and water. Neutralization means that I add sufficient amount of acid according to the mole ratio to the base according to the mole ratio, so that neither the acid nor the base are in excess. They will react completely, and once we have allowed the reaction to take place, we will no longer have any of the acid and base we started off with, and we will only have the salt and the water. That is what neutralization means. It means we add sufficient amount of the acid to the base so that they can stoichiometrically react according to a stoichiometric ratio, and neither of them is in excess. But what will determine whether the pH at the end is 7, lower than 7, higher than 7, is the type of salt that forms. Because as we know, a strong acid will form a weak conjugate base. A weak acid will form a strong conjugate base. A weak base will form a strong conjugate acid, and a strong base will form a weak conjugate acid. So what will happen is the salt will then contain a strong or weak acid, a strong or weak base that can react further with the water. That is what hydrolysis is. And that will determine the end pH and therefore the type of indicator that you should use during a titration. Again, neutralization does not mean the end pH is 7. It means we have reacted enough acid with the base so that they react completely to form a product. Neither is in excess. That's why we speak about over-titrating, where you add too much of the substance from the burette to your conical flask. Okay, are there any questions? Okay, auto-ionization. Guys, you don't need to know much about auto-ionization except this formula is incredibly useful. Okay, please make sure that you know how to use it. When we give you, for example, the concentration of the hydronium ions, you can use this to find the concentration of the hydroxide ions and vice versa. This is a very important formula. Please make sure you know how to use it. The pH scale, we know pH is negative log, the concentration of H3O+. Biggest mistake you guys make in your test is, we might have something like this. Sorry, let's change this. And let's put a 2 in brackets. The biggest mistake you guys make when you do this calculation is that you start off, and let's go put a number. I'm actually making mistakes. Give me a moment, guys. H3O+. For example, let's say you have something like that. There you go. So let's say I give you the pH and I say determine the concentration of the hydronium ions. The biggest mistake you guys make is you forget to divide both sides by the negative. Okay, that's the most common error. Please remember over here to divide by the negative sign first before you go and press shift log and find the concentration. Okay. Monoprotic, diprotic, this is going to affect your calculations. Monoprotic would be a substance that can donate 2 protons. Diprotic can donate 2. We speak about diprotic acid sometimes as polyprotic, meaning it can donate more than 1. You can use those terms interchangeably. Okay. On the next page, you're going to see a summary of your hydrolysis reactions. This is very important. Guys, sodium ions, potassium ions, lithium ions do not undergo hydrolysis. Chlorine ions, sulfate ions, nitrate ions do not undergo hydrolysis. Please go and learn this off by heart, okay? But your carbonate ions, your acetate ions, your oxalate ions, or your ammonium ions, they do undergo hydrolysis, and here are the reactions that you can use. Please go through this, and if you battle with this, I copied this from Dr. Swanepoel's notes, the same person I keep referring to when I refer to this chapter. So please go and watch that chapter so that you know your acids and bases very, very well. Okay. Are there any questions? Can I move on? Guys, we only have 8 minutes left. 8 minutes. Okay. So I'm not going to work through this. You guys will go through it in your own time. I'm sorry we spent such little time on acids and bases. But again, please use the videos. I quickly want to go to this section, electrochemistry. IEB learners, if I'm not mistaken, you only get one type of table of standard reduction potentials, and I think it's our table 4B, I think. You guys must just make sure. But if you are doing the CAP syllabus, you get both table 4A and table 4B. Choose one and work with it. So I like table 4A. Apparently it's not common to like table 4A. Most people like table 4B, but I prefer table 4A. So because I teach with it, I advise my learners to immediately, when they go into the exams, to cancel or draw a line through table 4B. But that does not mean that you must not be able to use table 4B, because sometimes we can take a snippet from either table and ask you questions about it. So you must be comfortable with both, but of course choose one and become more comfortable with that one. Guys, in both tables, we have our, reducing agents on the right-hand side. We compare reducing agents with other reducing agents. We have our oxidizing agents on the left-hand side, and we compare oxidizing agents with oxidizing agents. You cannot compare things on the left with things on the right. If we ask you guys to write down an oxidation half reaction or a reduction half reaction, do not write down a double arrow. If you do so, you are going to be penalized. You either write down the reaction that happens that way or the reaction that happens that way. But please do not use a double arrow. Okay. You're going to see on this page, I summarize all of the different things you might use to help you remember. For example, oxidation is loss, reduction is gain, oil rig. Or some of you know LEOGA. We know a substance that is the oxidizing agent is reduced or undergoes reduction. The reducing agent is the substance that is oxidized and undergoes oxidation. Anode, we have oxidation at the anode, we use NOx. And at the cathode, we say red cat. Okay, to remember, reduction takes place at the cathode. Use these in order to help you. Okay, remember, I have created videos on these, but because of copyrights, I don't have them on the website. So if you guys would like those videos, just send me an email. You just say Junior Tukkie, and I will know what it is for. I have access to lots of past papers, documents, multiple choice things. So guys, if you just send me an email, just say Junior Tukkie. I don't need to know your name. I'm not going to spam your account. I'm not going to say anything else except send you a link with videos and documents. That is it. Okay, so if you want that, just send me an email. My email's all over this document. Here it is. Okay, so you can just send an email to that. But I go through all of this and you can make use of it. Okay, not going to go through this. This is grade 11 work, which you guys know very well. But about your galvanic cell. Another name for your galvanic cell is a voltaic cell. Please remember, your cell phone, if you are using your cell phone, and it happens very often with your older cell phones, like mine, they tend to get hot when they are charging, or even when you use them a lot, they get warm. I use that to remind myself that since my cell phone battery is a galvanic cell, exothermic reactions take place in a galvanic cell. Okay, remember that because we do ask about it. If you look at your galvanic cell, you guys have gone over this and over it and over it and over it again. In your galvanic cell, the anode is negative while the cathode is positive. But it gets so confusing because in your electrolytic cells, it's the other way around. So let's quickly go to the electrolytic cells, just very quickly. Electrolytic cells is the last thing, so it's on the next page. It's the last thing you do in the year. So what happens? You start to panic. And that is how you are going to remember the side that is positive and the side, or the electrode that is positive and the electrode that is negative. For your electrolytic cell, we say panic, which means positive anode, negative is the cathode. If in an electrolytic cell, the anode is positive and the cathode is negative, then in the galvanic cell, it's the other way around. And you can memorize that and you're going to be okay. All right, so you just begin to panic and you're going to be fine. In your electrolytic cells, we have an endothermic reaction. It's a non-spontaneous endothermic reaction. The thing that you guys struggle with the most is these reactions, like for example, the electrolysis of sodium chloride. Because the reaction takes place according to whether or not it is concentrated or dilute. What is happening over here, grade 12, is we have a container, and in this container, we have sodium ions, Na+, because this is concentrated sodium chloride, and we have water as well. There are three different things competing to be oxidized and reduced. So what happens is, or what I would do is, I would write down the reaction or the half reactions for all of these. Water, we say, or let's rather go to this table instead. So I'm unfortunately making use of table 4A. It is right at the back of your summary page. But on this table, we have the reactions for water over here. I just need to find them very quickly. So over here, we have the one reaction for water. This over here is the oxidation half reaction. If water undergoes oxidation, it's at negative 0,H3 for both. And if we move towards the top, I just need to find the correct one. Here it is. If we are talking about, nope. If we are talking about the reduction of water, then we use this reaction over here. Other way around. I've made a mistake. So in this container, we have water. Water can undergo, according to this, I'm going to zoom out a bit, it can undergo oxidation or it can undergo reduction. Make sure that you know both of these equations. 2 more minutes and then I'll be done. Okay, make sure that you know both of these, please. Remember, positive 1,23 and negative 0,83. This is your reduction and oxidation of water. We also have in this container sodium ions. Here they are. And sodium ions have to undergo reduction. But we also have in this container chlorine ions, and chlorine ions undergo, just like the water, they undergo oxidation. Okay, so because we have all of these things, we need to compare. We need to compare water with chlorine. Okay, now according to this table that I'm using, water is a stronger reducing agent. Water is a stronger reducing agent than chlorine, which means that if one of these two things need to undergo reduction, it would be the water. But if the solution is concentrated, then we make an exception, and in that case, we will have that the chlorine ions will undergo oxidation instead. It's a reducing agent, so the chlorine ions will undergo oxidation. Because, guys, the chlorine is a concentrated solution. Now, if we go to the bottom, we have either water or sodium ions that will act as oxidizing agents and therefore will undergo reduction. According to this table, water is a stronger oxidizing agent than sodium ions, and it will therefore undergo reduction instead. So that is why if we go back to this paper, you're going to see where I indicated that this is a concentrated solution of sodium chloride undergoing electrolysis. We have, instead of sodium ions, we have over here the reduction half reaction is water undergoes reduction. And instead of the water ions, because it's concentrated sodium chloride, the chlorine ions undergo oxidation. It's a little bit complicated. Like I said, if you guys need more on this, you just send me an email and I will send you guys more content on it. But we've unfortunately run out of time and I think it's lunchtime. Okay, so guys, thank you so much for your attention. I wish you guys all the best for your exams. The ball is now in your court. Study hard.